Well, we promised you an update on some of our fossil discoveries videos once we got back to an electron microscope, and now we have. So was that strange Silurian creature with the weird organic fibre skeleton the same as the banded tubes that are picked up by palaeontologists? And that sea slug from Castle Bank, is it really a sea slug? Does it have teeth? I'm here to tell you today about what we've discovered, what there is still left to answer, and where we go from here. Welcome back, or welcome for the first time in some cases. But if that's the case, you might want to go and see the previous videos. There's 2 of them which lead up to what we see today, because there were a couple of mysteries, things that were unanswered questions, and those other videos give you the introductions to them. Okay, so the first one was a strange Silurian fossil, or a series of fossils, which we've been finding in the rocks around here, made of little organic fibres. And this is a strange skeleton. It doesn't seem to match anything in particular. But the filaments themselves appear to be scattered very widely through the rocks of this age and into the Devonian as well, where palynologists, so people who study spores and pollen and so on, have been finding them and describing them as banded tubes, where they were thought to be related to the origin of land plants, possibly. Or possibly fungi, or some other group. So they're a bit mysterious and no one had ever seen a whole one. So we're going to find out whether these are the same as the banded tubes, and if so, can we work out what the animal or plant or thing really was. The other one was even further back in the stream of videos. We had one where we discussed a strange fossil from Castle Bank. This is this extraordinary Ordovician deposit where we have soft-bodied animals preserved in abundance. And this one in particular we highlighted as possibly the first fossil example of a sea slug. We found quite a few features that matched, and then just about possibly we thought we could see a radula, which is its sort of tooth-like mouthparts. So we needed to get that into an electron microscope as well in order to see whether it really was. So we've been back down to the National Museum in Cardiff, where we have access to a nice little Scanning Electron Microscope, or SEM. And amongst other things, you just know what we've put into it to have a look. So today we're going to be showing you some of those results and discussing the possibilities for how to interpret them and see where we go from there. And some of you have never probably had a chance to use an electron microscope or see one in action. So we've taken a little bit of footage to show you what it's like. I will warn you that because it's in a sort of enclosed, echoey room with machinery whirring and all the rest of it, and we don't have great microphone equipment yet, the sound is pretty bad. But, you know, we'll show you some snippets of how that all works. So SEMs used to be, this is Scanning Electron Microscopes, used to be about the size of a room, and I remember those days. But this is the one we're using here. It's ridiculously small. It's a desktop. This is a desktop SEM, the cheap and cheerful cousin of the ones that fill the rooms, but it's still a very nice machine. The specimen goes into this chamber, and then it pumps down to a vacuum because the electrons get interfered with by air. So we have here this specimen of the potential banded tube organism, this sort of hairy thing which is on there. We, in the old days, would have gold-coated the specimens to make them more conductive, but the machines nowadays can cope with that. I've used a sort of conductive tape conductive blue tack effectively, to stick this onto these aluminium supports, which is then getting it to exactly the right height, and we're going to put it in and see what happens.
Right, so I'm going to put the specimen in. So it goes in there. I'm wearing gloves to minimise skin flakes going in there, because those will muck up your things. Having it over very carefully. Drop it in. Stick it into place, and then there's a very strict height limit, so I'm going to be very careful when closing this, just in case it's too high. How are we doing? No, I think that's all right. Yes, that's fine. So, hold this close and there we go. Starting to pop down.
It might take a little while. Okay, we've just put it back in again after having to take it out because it wouldn't quite fit into the stage in the right area, so we couldn't quite find the fossil. But this is now improved, and it's got this really handy camera which allows us to zoom into the bit that we want to so that we don't spend hours, it can be literally hours, finding the bit that we actually want to look at. So, fingers crossed, this will actually work. Using an SEM often involves a little bit of waiting. Please hold the line. Aha. Right then, let's have a look here. So, let's see, observation, let's go for surface. Various settings you have to do to let it work out what it's doing. All sorts of different modes you can operate this in. It's now running autofocus and changing the accelerating voltage, and yeah, it's amazing. In the old days you'd have to do everything manually, including checking for astigmatism, and it's yeah, it's far easier with these new machines. Okay, this is on quick scan mode, so we go to slow scan. It will give us an actual image, and now we find the bit that we want, hopefully. That looks like it might be it.
Yeah, there are the parallel whatever those fibres are.
Yeah, okay, this is very low magnification. That... Oh, this is really interesting. This is retiolited. So that gives us the organic preservation. Those are not preserved in the same way at all.
Right, let's get a good photograph.
As you can see immediately, the graptolite is preserved, or it appears black in the electron image, because it has very low density, and that's consistent with carbon. In the mystery fossil, though, you've got some black lines, but also a lot of what appear as white lines, which means a much denser material that isn't carbon. That is intriguing.
So here we're doing what's called an elemental map, which is a map of the different chemical elements that are present on the field of view. So this will enable us to see what these two things are made of.
We know that the retiolated graptolite was carbon, so that gives us a direct contrast with what we're seeing in the
So I will
tubes.
click start. Oh. I think we
Carry on.
carry on.
Yeah. So
We can always do it again if it doesn't work very well.
So what's it doing now?
Right, the machine is starting to scan the surface. It's seeing what elements are there. Now let's see. We've got some carbon that's not really showing up well. Lots of silicon, that's not unexpected. It's a siliciclastic rock. What else have we got? There's lots of aluminium again, that's silicates. There's a lot of calcium, that's surprising. Potassium, yes, you get that in clay minerals. Oxygen you get everywhere. Iron is not unexpected. What we are not seeing, oh yes, there is a bit of calcium there. We're not seeing much carbon, but we still have another 40 seconds, so we'll see what turns up.
Okay, so this is a map of very fine details. There's a 10 micron scale bar. This is one of the fibres running across the middle, and the impression of a fibre in some sort of matrix material. And what we see is we've got some carbon, not as much as you might think, but some carbon in the fibre itself. And then, strangely, there's blobs of magnesium all over the place. Then we go down to here, and we have calcium. So we're going to have to compare with graptolites that are preserved right next door to it to see if they also have a sort of calcium residue over them as well, in which case there may be some secondary effect of calcite precipitating in spaces, for example. So that's something we're going to have a look at. When we did a map of the retiolated fibres, we also see there's a bit of a trace of carbon. That doesn't show up very well in SEM because it's such a light element. That's a known problem. But the calcium is there as well. It's just a very faint little ghostly outline of it. But in the electron image, you can see that it's alternating the black carbonaceous material and something else which is more whitish or silvery. So it does make sense for being very similar preservation of the retiolated fibres as it is in the fibres of our weird fossil. So that gives you a flavour of what we can do with a machine like that, and it's really a lot of fun, isn't it?
Oh yes.
Yeah, you can't get much more entertaining than sitting in a windowless room all day with buzzing machinery everywhere. It means you're doing proper science. Anyway, it took us a while to work out the detail of that preservation with the apparently calcitization of organic matter, but that seems to be a general pattern at this site, that any organic material that's preserved has a bit of calcite stuck to it, or inside it, or around it. And there was another little bit of preservation that was quite interesting as well, wasn't there? Around the apex of the fossil, where it looked in the light microscope that there was sort of brown stain. We can actually show that in the elemental mapping.
Yes, that showed up very clearly. There's a lovely film of iron just over the surface, just where the fossil is, and hardly any iron outside the fossil. So that's got to be where the soft tissue was.
Yes, so you might be wondering why iron, but a very common mode of exceptional preservation is pyritization. So it's all been weathered to a pretty severe extent. So there's no sulfur left there, which would be pyrite is iron sulfide, and we would hope to see the sulfur, but that's not there anymore. So it'll be iron oxides.
Yeah, which explains the brown colour. That's what the colour they're weathered to.
Yeah, and this actually matches what we've seen in sponges in there as well, that there is a thin film of iron oxide over the surface. So it does look as though it was genuinely a little bit of soft tissue preservation there.
Yes, not enough to give us any detail, but it's nice to know that it was there.
Yeah.
And it does show that this was the whole thing, or at least a big part of the thing, rather than just an isolated bundle that had been eroded out and all the soft tissue had decayed.
Absolutely, and if it had been torn, we should see bits of soft tissue and a ragged edge and so on.
So we don't see that. So that gives us a bit more information.
It does. So it looks like what we're looking at here is the real thing. Okay, so what sort of real thing is it? What have we learned?
Well, we're still a bit baffled. I mean, we've seen that this thing does consist of a parallel bundle of fibres. We wanted to know whether they were the same as the banded tubes. We're still not quite sure whether they're tubes or not. We haven't seen anything that definitely says it is a tube.
It's very difficult, of course, because you're seeing them when they're lying flat. And in the broken open surfaces, there's possibly a faint hint that one or two of them are hollow. But I'm not convinced.
I think more to the point, reviewers wouldn't be convinced. So we'd need better information on that.
The other thing is, going back to the question of are they the banded tubes at all, is that we're not seeing any sign of any regular banding on the outside or inside, but we're not seeing the inside. But yeah, the outside is showing nothing. In terms of size range, apparently they're about right.
Yes, they fit within. Some banded tubes are a bit thinner, some are a bit thicker, but they're ours are about 25 microns wide, which is about right for the banded tubes. And some banded tubes that have been illustrated in the literature don't show sort of thickenings on the outside. So I think from this specimen, we can't totally rule it out that they're banded tubes, or they're not banded tubes, but it's looking less likely.
Yeah, I think we haven't seen any of the features we would hope to see. And in many of the examples that have been illustrated with transmission electron microscope, for example, you have very clear ridges on the outside as well as the inside. And I would hope to see that in at least one or two of the ones we've got.
I would hope so too, but we've only looked at one specimen, and if that happened to run with very smooth tubes, we could just have been unlucky. So we do have more specimens of the banded tube thing. Well, of the tube thing, of this, whatever that is, thing.
Of the thing.
Of the thing, yes. Unfortunately, the one I blocked that was too big to go in the electron microscope.
So I need to saw that one down very carefully, and next time we go back we'll try a couple more of those. And also just to confirm that we're seeing the same detail.
Yes.
Another thing we can do is take some of the fragments of these and actually cut them transversely. Polish them maybe? You can try polishing them. A little emery disc and some water.
Yeah, that might just obscure details if you actually end up putting stuff over them. We might need to try a couple of different things, perhaps.
Yeah, but what I'm trying to get at is we can have a cross-section and we can put that vertically in the SEM so you can actually see whether these things are hollow.
That would be the smoking gun, wouldn't it?
It would, to some extent, although more than one thing is hollow.
Yes, but at least if they weren't hollow, we could say they weren't the banded tubes.
Correct, yeah.
So that would be important evidence either way.
Yeah, so it's looking as though our hunch is that these are different. That there are actually in the literature loads of little filaments and tubes and so on that you get in this sort of age rocks. And the banded tubes are one particular one that have received focus from palaeontologists and botanists. I think these are different now, but we can't prove it 100% yet.
So, like most of science, you learn a bit more and then you need to do more work.
Oh yes.
Oh yes.
But, on the other hand, if they are different from the banded tubes, as we think, then that does give us a little more freedom in interpretation of these things. Because one of the problems with the banded tubes is that they turn up in terrestrial river sediments as well, so fresh water. And if they are something like sponges, that's actually very difficult. Oh, yes. There's only one family, really, of sponges that's adapted to fresh water.
And it's definitely not those.
Absolutely not. So, if sponges were an option, and they might be still, then, yeah, we might do something with that. Have we got any further with interpretation of what sort of organism they were? Unfortunately,
not really.
The specimens are a little bit, rubbly is the wrong word, they're not beautifully preserved. The edges of these bundles are slightly obscured by crystals and sediment grains. They seem quite irregular anyway.
I mean, we have confirmed that they were carbon, which we pretty much knew already, but it's nice to be sure.
We've also confirmed, I think, that the ones sticking out the top are actually a little bit more robust. They're slightly larger. We'll check this one, but I think that is the case. And also one other feature that we have seen is that there are some longitudinal structures. There are little ridges running irregularly along the length of some of these things.
Yes.
And the way that they crease is also suggesting sort of longitudinal ridges. So that is something you never see in the banded tubes. Yeah. But you do see speculate sort of wildly in the things like Linica.
Oh yes. Oh yes.
Which is that group of sponges that we were thinking might be possibly an analogue for these, or a homologue even, where you have this thick organic outer layer in the ascosponges, this extinct class. And in some of them, like Linica especially, there are longitudinal ridges, quite striking ones, on the outside of the organic layer of these spicules.
Ooh, but in Linica the ridges are very, very, very obvious, whereas this is quite subtle, and in Linica they were quite consistent all the way along the spicule, as I remember.
No, they are quite irregular.
Oh, are they? Okay.
And different in different species.
Yes, that's true.
So Linica hindii, for example, from Burgess Shale, they're a lot fainter, but they are there.
Yes.
But it is a longitudinal ridgy structure. I mean, obviously this isn't Linica. It's a totally different looking thing.
Yes. I mean, Linica has got it's a sort of bowl shape made of spicule. Yeah.
Yes, just like that.
Yeah.
No, that's a dead one.
Yeah. Coin is often reconstructed like that, but that's totally wrong. It should be like that.
Yes, we actually have some with the root tufts at the bottom, so it was sticking up out of the seafloor like that.
Right, that's today's bonus sponge content. Right, back to the banded tubes.
So it is possibly a parallel and a feature that you might see as being relevant. So if this is some sort of derived member of that group, then longitudinal ridges on the surface is something which is already known in that group.
Yeah, but it would be quite a different structure because in Linica you had the outer organic layer, you had the calcite layer, then you had the silica layer, then you had the axial filament. And presumably all the mineral stuff is missing. It's not like it could have been there and dissolved.
Presumably, but we are getting an interesting calcite signal, aren't we?
Oh, so you think that might not be taphonomic?
Well, you notice that we're getting that calcite signal on the entirety of some of those fibres, which were turning up as black in the SEM, which means that there wasn't a crystal veneer on the surface. So either it was quite porous organic stuff which had microcrystalline calcite embedded within it, or it was going straight through the carbon as it does normally and hitting something that's inside it.
Ah, well, if it's going straight through the carbon, it could be hitting calcium carbonate that's coating the fibre within the rock.
Or filling in the cavity in the centre.
This is something where a thin section might be really useful.
It might be, yeah.
But at that point we might be wanting some more specimens just so we can afford to slice one or two up.
Yeah, we might have to go and get some more.
I think that would be a good idea.
But of course we can do a lot with the fragments, the little bundles that we find loose in the sediment as well.
True, yes.
But, so you can see where all this is going. We don't know the answer yet. We know quite a lot more. We're looking increasingly towards the sponge option as the one to disprove.
But there are still problems with that. So, but then we haven't really got a better idea at this point, have we?
No, and don't forget, going back to, your problem with the loss of the internal mineral component. There are some spicules in sponges in the Sirius passive biota that we've described, for example, that actually have very little internal mineral component. There's a sort of axial rod, and that fades out towards the end.
Okay, yeah. It's possible that things do lose minerals all the time, so yes.
Chancelloroids.
Yes.
So, so we're getting somewhere, I think, but there's a lot more to go on that one yet.
So this is science as it is happening, but we'll let you know.
Yeah. Someday. Yeah. You'll see it here first.
Oh, yes.
So that was one of the things we really wanted to show you. The other one is this possible sea slug. Now, this is a slightly sort of sensitive one because if it is genuinely the first fossil sea slug, then that is potentially quite a high impact paper, and we are slightly limited in what we can tell people about on a publicly accessible channel, because that tends to have implications for press embargoes and things like that if you were to get a high impact paper out of it. So if we didn't find anything, then we could tell you everything we found, and it's just a cautionary tale.
Yes.
And if we did find what we were looking for, then we might have to be slightly more circumspect.
Yes.
It's a tricky one, isn't it?
Well, we're both smiling broadly, which does give you a bit of a hint.
So what we were looking for, just to remind you, and in case anyone foolishly hasn't watched the other video first, is...
Watch all the videos and don't forget to like and subscribe, please.
Thank you for that, yes. So, what was I saying? Yes, what we were looking at is this thing that looks like a sea slug. It's obviously soft-bodied, it's only about 3 millimeters long, it's a tiny thing, but it has certain features that look very sea sluggy, which includes, coming off its back, these sort of branching paired gill-like structures, which there's virtually nothing else we can think of that has any structure like that, which is why we were looking at it and thinking, okay, this could be a sea slug, maybe. How do we go about proving it? And what we came up with was, if it's a sea slug, it's a mollusk, and it has a radula. And a radula is a sort of evil, scrapey sort of ribbon device with silica embedded in it. Actually, it's quite tough structure.
Yeah. The way that Joe's refers to it as evil, he does try to grow cabbages. The slugs like his efforts over the year. Yeah, the radula is very, very effective at scraping things away.
They carve rude messages into courgettes and everything. Well, yes. So the radula is a ribbon arrangement of lots of tiny little teeth, little curved hooks and things like that, it's a very distinctive structure.
And only mollusks have it.
So if you were to find that structure, then you'd know it was a mollusk, and then by default it's got to be a sea slug.
Yeah. In fact, one particular group of sea slugs.
And we could even see in the light microscopy, in the microscope got here, that there were some little hooks that were about the right size in the right sort of place to potentially be radula. So that's what we went to look at.
And we looked at it.
We did. It was fun, wasn't it?
It was very, yes. Yes,
Yeah.
we had a very nice morning at
Yes.
the SEM.
Yes, there
Yes.
was there was stuff to look at.
There
Yes.
was definitely stuff to look at. We got
Yes.
some nice pictures.
Yes.
Yes.
Yes, so this stuff to look at. You might be hoping for a sort of fully developed, great big ribbon with covered in little spikes all over it.
That would be nice.
But it turns out that that is a sort of late stage development of a sea slug radula. And in fact, if you're looking for the early growth stages up to about 3 millimeters, for example, some people have kindly already published this stuff on modern ones. What you get instead is a series of little sharply defined hooks.
Let's call this the free radula. So before the radula develops, you get a sort of little baby radula.
Yeah. And they're attached potentially to the early stages of the, well, those are the marginals, and then you've got the laterals. And the laterals have a sort of stubbier form. You might hope to see little bits like that.
Yeah, you might expect to see more than one morph of little toothy bit.
Yes, you might.
If you had a radula.
If you did.
If you did.
Yes.
Yes.
Which would be quite exciting if we did.
It would be very exciting if we did.
I mean, how would it be preserved if it was, for example, to be preserved in a case like this? What would you expect to see?
I suppose you see little key bits.
Yeah, but would they be three-dimensional, or because they're organic, of course? They're not really they're not easily fossilisable structures at all.
Except somewhere like Castlebank.
Yeah, well, there you've got soft tissue and tougher tissues. So you might expect to see slightly three-dimensional impressions with little ridge down the edge or something like that.
Maybe.
And if you're really lucky, you might see several of these in one small area, on that sort of arrangement.
Well, you'd want to see that to prove it was a radula rather than just a random little hooky bits overlying.
You would indeed, yes,
Yes.
yeah. And you wouldn't be happy at all until you'd found that, would you?
Oh, well, I'd be very depressed.
We would really like to be able to go into everything we found, because it's actually more than that. There's sort of internal soft tissue structure as well that might be interesting if any such thing were to be found.
If any such thing
Yes.
was to be found. Yes. We do love talking about this sort of thing, especially to people who make nice comments about it afterwards.
But we've been thinking about how on earth we can do that in a setting like this. And the main problem that we have to avoid is having critical information published available for free online.
Before we publish it properly in a journal.
Yeah, after that it's all fair game, of course.
Yes.
And this does actually quite neatly coincide with, there's been a few requests from people here who are saying that they would be very happy to actually pay a little sort of monthly subscription to a membership, for example. And this actually does bypass the issues.
Yes. Because if, hypothetically, there were to be members-only videos only available to members, it wouldn't be publicly available.
It wouldn't.
Any information on any sea slugs or Amgueddfa or any other amazing stuff that we might happen to have lying around.
Yeah, I mean, some things have turned up in conferences, but again, that's sort of not publicly available stuff.
Yes.
So it's a way that we can have of putting out extra videos. It wouldn't interfere with what's going on the public side, because we want to carry on doing that anyway. But extra things that we also want to talk about in more detail, showing some of the more spectacular unpublished stuff. Not necessarily even from Castlebank alone. I mean, there's other papers that we're working on and things like that we could discuss.
So how many of these might you want to do per month, say, Joe?
Well, I would be thinking something like a couple a month, something like that would be good.
1 or 2, depending on how long they were, I suppose.
Yeah, that sort of idea. Not so many that it interferes with us being able to generate our normal 2 a week of this or more normal format, but just be able to do a bit extra for those who want to support the channel and support us and our research, in fact. So if people did want to become members for what we decided,
About £3 or £4 a month, wasn't it?
So we could then open the membership. Anyone who would like to support it then gets an added bonus as well. So there's no compulsion to do anything like that, but it's a way that we can talk about some of the the really more exciting, groundbreaking stuff that is not yet published and may not be for a good long while, and which allows you to sort of get a bit extra out of it.
Yep.
So, yeah, I don't know how that's going to work. We'll see if there's any demand, really, I guess.
Yes.
And I will launch the membership post-haste and see if anyone takes it up.
That sounds like a plan.
Yeah. But regardless of that, thank you all very much again for staying with us and listening to our weird ramblings on strange fossils that defy explanation. Oi.
Nothing.
And we will be back in due course with something else. I was waiting for someone to shout graptolites then, but luckily it doesn't seem to have happened. Oh well. You never know.
He'll do them anyway. He likes them.
We'll see. Fare you well.